She is a good poet in Marathi language. So let Ms. Pratiksha Kadam ma'am to start his speech on Python programming language. She is going to explain the Python. Okay, ma'am, you can share your screen.
Thank you so much, sir, for the kind introduction. Friends, today I'm going to talk about Python programming language. Of course, the title is Introduction to Python Programming Language, but I will not tell you what all data types are there, what all basics are there in Python programming, because many of you might know those basics. So basically what we will focus on is the important libraries which are there in the Python programming and which are useful for data analysis purposes. So I will share my screen with you all and we will begin with the today's presentation. So we are going to discuss about Python programming. So flow will be somewhat like this. We will first see what Python programming is, then some libraries which are there for data analysis, which are there in inbuilt libraries in Python, which are there for data analysis. Then we'll work with data. We will see basic descriptive statistics, then graphics in Python, and I will just give you a little bit of introduction to basic statistical analysis. And there are two libraries which you can use for statistical analysis, and these rich libraries make Python very rich, and it is in demand. Many industries demand Python programming language. So this is a very good tool for data analysis. So let us begin with about Python programming. So it is basically, this language is not a recent language, or since this language is not used much in earlier days, it has become popular in recently 5 to 10 years or maybe 15 years. But it was developed in 1980 by Guido van Rossum at CWI, Netherlands. After he developed this language took implementation also took such a big span of 9 years. It was implemented in 1989 and then it was formally released to use in 1991. This language is object-oriented language, high-level language. High-level languages are easy to code, easy to understand the code. This is interpreted, that is every line is converted to machine code when you write the program. And this is mainly an open source language, and that is the main feature for what this language is more popular. Another thing is it has a large standard library. So this language has rich library as well as it has many data types. So more other than numbers, text values, Boolean data, it has some more data types like tuples, lists, dictionaries, and sets. So and it has good libraries in which you have many inbuilt function and which you use in different analysis techniques also. Code can be executed on almost every platform. This means the language is portable. When you write a code for a particular task in Python, that code can be executed on your Windows platform, on macOS platform, Unix, Linux, even on Android platform. As well as this language has many online editors also available. So today we are not going to install any software, or if you have Python 3 or you have Anaconda or Spider or Jupyter Lab, you may have any of this, you can execute those codes there. But if you don't want to install a particular software, you can also use Google Collaboratory. What is the requirement is only you need one Google account for this. And then you can execute your code on that Google Collaboratory as well. There is another platform called Jupyter Lab. You can execute that code online on Jupyter Lab as well. The benefit of Google Collaboratory is your work is saved in your drive. So you can have access to your work again and again. So today we will run the code on Google Collaboratory, whichever examples we are going to learn today. So this is easy to code language and also supports graphic user interface. And these are the key features which make this language popular. So let us start with the okay. So let us start with the libraries which are there for data analysis. The very first library is NumPy, and NumPy stands for numerical Python. So this numerical Python gives us a very important and very strong data type, or data structure rather we can say, which is called as array. And multidimensional arrays, if you want to deal with multidimensional arrays, which are required in matrices, maybe required in linear algebra, this NumPy package or NumPy library is used. So it provides the mathematical functions to handle large dimensional array, then provides various methods for matrices and linear algebra. The main object is homogeneous multidimensional array. That means what? In this array, all the elements, suppose NumPy, you are creating an array using NumPy, then all the elements of this array will be of same type. If you're using integer values, all the elements will be integers. If you're using float values or decimal values, all the values will be decimal values. So in NumPy, dimensions are called axes and the axis is called rank. So if you have 2 dimensions, so there will be 2 axes, and if your data is 2-dimensional data, the rank of this array is called as 2. Now we will see a little more about NumPy. I will request you to tell me if you are able to see the next presentation when I click on this. Is this visible to you all? Can I get some answer?
Yes, yes.
Okay, thank you, sir. So we will see a little more about NumPy in detail now. So what is NumPy that we have already seen? It's a numeric, it stands for numerical Python, and features of NumPy are a powerful n-dimensional array object, sophisticated broadcasting functions. Even you can integrate the code from C, C++, and Fortran in NumPy. It is useful for linear algebra, Fourier transform, random number capabilities as well. And this is the most important thing. NumPy is not used uniquely, or alone. NumPy is not used. Rather, it is used with the in combination with SciPy or Matplotlib, because NumPy will generate an array, and that array or that particular object can be used or can be worked. You can work on that particular object using the functions that are stored in SciPy or Matplotlib for plotting the graphs and all. So this combination, basically, we know that MATLAB is a very popular software for technical computation, and this particular NumPy, along with SciPy and Matplotlib, is a very good replacement for MATLAB, and it's a free replacement. So this is the reason why NumPy is very popular. Now we will see how to generate the arrays using NumPy. So first is installation of NumPy. Now there are 2 ways. If you are using Google Colaboratory, you don't need to install these libraries, NumPy, then you have Pandas, and then you may have SciPy and some more libraries. But if you are working on a local software, that is, you have downloaded Python 3, or you might have downloaded Anaconda or Jupyter or Spider, what you need is, initially at the beginning itself, you have to install NumPy, and for that we use pip command. So to install that, the command is pip install NumPy. And where are we going to write this command? We will execute this command in the command prompt. Once you execute this command in the command prompt, you are the installation of NumPy takes place, and you are given a message. Once the installation is complete, you are notified that the NumPy is successfully installed. Once NumPy is installed, then only you will be able to use all the NumPy features in your programs. Unless you install NumPy, you cannot use those features in case of local software which is downloaded and installed on your device. In case of Google Colaboratory or in case of Jupyter Lab, you don't need to download this or install these libraries, because those libraries are by default installed in those platforms. Okay, so this is how we can install NumPy. And now we will see what is n-dimensional array in Python. The most important object defined is an n-dimensional array type called as ND array. It describes a collection of items of the same type, because it is homogeneous, it contains homogeneous objects. Items in the collection can be accessed using zero-based indices. So always remember, in Python, the indexing starts with 0. So the very first element will be called as 0 if you are dealing with 2-dimensional array. If you're dealing with 1-dimensional array, that is a simple array, the first element will be 0th element, that is called as zero-based index. Okay. If you're dealing with 2-dimensional arrays, 0, 0 will be your first element. First element position, not first element, the position of the first element. Every item in ND array takes same size of block in the memory. each element in ND array is an object type. Data type is called as object. Okay. So let us see some structure of ND array. So this is one ND array defined. So A00, A01, A02. So this 1, 2, 3 is A00 position. This is 01 position. This is 02nd position. And this way the positioning is taking place in n-dimensional arrays in NumPy. But how do we create these arrays? We know how the positioning is done, how the data is stored, but how to create these arrays, that is more important. Now, let me tell you, there are different data types in, as I told you, in Python, numbers and strings. Along with that, there is list, tuple, dictionary, and a set also. Now you can create this NumPy using a list and a tuple as well. So what is a list? If you assign the values, set of values stored in square bracket, that is called as a list. Whereas if you assign the number of values stored in round brackets, that will be called as a tuple. Then what is the difference between a list and a tuple? Lists are mutable. That is, you can change the elements of the list, but tuples are immutable. You cannot change the elements of the tuple. So depending upon the use of, depending upon the use of those particular objects in your program, you can decide whether to go with the list or whether to go with the tuple. And then you can design the NumPy array. Now, there is an array, a simple array also in Python, and this is a NumPy array. So what is the difference between the two? If you have to deal with the calculations of, say, 1000 by 1000 matrix, in that case, simple arrays will take a lot of time, whereas NumPy arrays do it quicker. So that is the reason NumPy arrays are preferred over the simple arrays. Now we are going to see a few examples of creation of these NumPy arrays. So you can see some code is written over here. Creating an array with the list with the type float. So for example, can you see the elements of this array? np.array, inside the bracket, we are assigning a list containing 1, 2, 4, 5, 8, 7. So this is two-dimensional array in which we have the elements as 1, 2, 4 and 5, 8, 7. And we have specified data type as float. Whereas if you look at the elements, every element is an integer. So if I don't specify the data type for these elements, the data type assigned will be integer. If you specifically write that this data type should be taken as float, then it will consider this as float value. And let us see the difference between the integer value and the float value in the array when we see the output of this particular code. Then they have defined another array with 1, 3, and 2. This is one-dimensional array. You design using a tuple. Whatever written into the brackets, 1, 3, 2 values, and those parentheses called make one tuple. And now we are designing the second array using a tuple. So array created using the past tuple is B, and we will see the output of that also. np.zeros. Suppose you want to generate an array of 3 by 4 dimension with all zeros, then there is np.zeros. np.full 3 by 3 array, 6 is the value and type is complex. Okay, so integer, float, now the type is complex also. So 6 is to be written in complex format. That means 6 into I plus 6 plus 0j will be the value. So let us see the output of this. These codes I'm not executing, but other codes which are a little complicated, those we will execute. So this is the output. This is the first array is creating it using the list. So this is your first two-dimensional array. This is one-dimensional array created using the tuple. Then this was the array, which is 3 by 4 dimension, 3 rows and 4 columns with all zeros. Then here it is another array. Can you see the elements 3 by 3 array with the elements 6 plus 0j, because we have specified that this should be of complex type. This is how you can generate the arrays. And there are few more procedures of generation of arrays. We'll see some more procedures. np.random.random 2 by 2. So it will generate a 2 by 2 array with random numbers. Then create a sequence of integers from 0 to 30 with step 5. So if I don't write the step value, then the default step is 1. Okay, so np.arrange is used to generate the numbers in a sequence. So if I want to generate 0 to 100 numbers, I can just write f is equal to np.100 np.arrange 0, 100 and complete the parenthesis. It will generate 1 to 100 numbers in an array, one-dimensional array. Create a sequence of 10 values ranging from 0 to 5, which are equidistant. So that can be done using linspace. np.linspace gives us the numbers from 0 to the given, or from given in within the given range with the equal distance and with those many values. So let us see the output for this as well. So this is a random array. Then this is a sequence which is generated for the values from 0 to 30. Step value is specified as the last parameter. And since the last parameter is 5 over here, you can see 0 after 0, it's 5, 10, 15, 20, and 25. And similarly here from 0, some equidistant values are done and 10 numbers are generated using linspace command. So these are linspace method. So these methods are applied on array, and you can design different types of array using different methods. Now let us move ahead and we'll see again there are some more methods of generating. So you can reshape the arrays. Suppose for example this is one array with you and you would like to reshape this array to 2 by 2 by 3. Okay, so this becomes a 3-dimensional array. Now this is a 2-dimensional array. Number of brackets beginning here will define the dimension of this particular array. So this is an array in which is 2-dimensional array in which your elements are 1, 2, 3, 4 is the first array. Second row is 5, 2, 4, 2. Third row is 1, 2, 0, 1. And if you want to reshape it and you write reshape 2, 2, 3, it is going to reshape your array in 3 dimensions and 2 by 2 matrices. Now, when it reshapes in 2 by 2 matrices, what it does is it will take the values in a sequence while reshaping. Similarly, flattening the array, if you have 2-dimensional or 3-dimensional array, flatten will make the array in 1 dimension, or it will convert the array to single dimension. And all the elements will be listed in a sequence. So you can see here, this is the original array. This is flattened array. So 2 by 3 is every element has two rows, and this particular array is a 3-dimensional array because you can see there are 3 brackets opening and closing. Then original array and the flattened array is also displayed over here. Now basic array characteristics. So you can import NumPy as NP. So before we start with NumPy and all these things, because we are using over here, you must know that every time though you have installed the library in NumPy, it is not necessary that particular library is available for you for programming immediately. Unless you call that library in the program, that library is not going to give you any functions, or any methods from that library are not available to you. So you should write import NumPy. As NP is optional. This as NP is an alias. So instead of writing NumPy again and again, because whenever you are calling a method, whenever you are calling any attribute from that particular library, you will have to write that library name followed by the attribute, or library name followed by the method. So if you don't want to do that, what you don't want to write NumPy again and again, similarly you may have to use Pandas, similarly you may have to use SciPy. If you don't want to use those names again and again, you can assign them a shorter name, and NP is conventionally accepted shorter name for NumPy. So we usually write import NumPy as NP. We design an array, np.array, and this is one of the array. So let us see what is the type of this array. What are the dimensions? So these end, dim, shape, size, d type, all these are called as attributes of this array. These are the properties of this particular array which are assigned to this array, and we will see the output of this. So array type is NumPy ND array. As we know that NumPy, the structure which is generated using NumPy, the array structure is called as ND array. So its class is shown as NumPy.ND array. Dimensions, two-dimensional array it is. Shape of the array, 4 by 3, because there are 1, 2, 3, 4 rows and 3 columns. Every row has 3 values. Array size, total number of elements in your array is your array size. So size of the array is 12. And what is the type of the array? You can see here every value here is an integer, and that is a short integer. So integer 32 is shown as a type of this array. Then the slicing can also be done. That what is the meaning of slicing? If you want to extract some values from the arrays, so you can use the start, stop, and step procedure. Where to start, where to stop, and before you stop, one value before the stop will be given to you. So you can see here np.arrange 10. What it will do? It will generate the numbers 0 to 10, 1 to 10 rather, and then slice 0 to 10, maybe 0 to 10. And S is a size from 2 to 7 and comma 2, and you get these values. This comma 2 is starting position, 7 is stop position, and 2 is the step value. After first value, which is the next value, is the first value plus the step value. Then same result can also be obtained by giving slicing parameters separated by colon. So either you write comma or you write colon in the separators. You can, but here you can see here slice is the function which is used. Here we are not using the slice function, rather what we are doing is we are writing the array name followed by the start, stop, and step value separated by colon into the square brackets. These both the methods can be used for indexing, for slicing the arrays. Then slicing a single item, fifth positional value, or 2 onwards positional values, or 2 to 5 positional values. So 2, 3, and 4. Only those values will be given. So this is slicing. I don't think I will do all the slicing values. Okay, so now these are some more slicing and indexing examples in which import NumPy as NP. This is a 2-dimensional array. You can see here, this is the array in the output. Array is, so array is printed as it is. Then the items in the second column are, so if you want to list the items in the second column, as you know that the second column will have index as 1. So colon, triple dot, comma 1, if you write, you are going to get the second columnar values. So the second columnar values are 2, 4, 5, and 7 here. Those are shown to you. Items in second row, 1, comma, triple dots will give us the second row values. Similarly, 1, colon, comma, and something will give us the values column 1 onwards, row 1 onwards, and so on. Using this, you can extract the different columns as and when, as per the need of your program. Now, the next is advanced indexing. So you can have advanced indexing also. Import NumPy as NP. This is an array. You can give the reference of over here for y, and then you can print the value of y also. So, so this is again, okay. If you want to extract the corner elements of the array. So this is one array in which you will have 0, 1, 2 in first row, 3, 4, 5, 6, 7, 8, and 9, 10, 11. The array is that output I have not printed here. Okay. Print x. Rows is equal to np.array 0, 0 to 3, 3, and columns is equal to np.array 0 to 0, 2. W is equal to z of rows comma columns. Then print corner elements of this array are. So what are the corner elements? First, you have to assign 0, 0 is the first value of rows, and 3, 3, because 0, 1, 2, 3 are the row numbers and the index numbers basically, and the third value will be your last value of your row. So 0, 0 to 3, 3 will be assigned for rows, 0 to 0, 2 will be assigned for columns, and if you print W value, you will be able to see a table, or rather an array, which shows you the corner elements of this particular array. So what are the corner elements? 0, 1, 2 is in first row, 9, 10, 11 are in last row. So 0 to 9 and 11 are the corner elements. We will see some more advanced slicing is there. I will share this advanced slicing slide, otherwise we will not be able to complete this. So we'll move ahead. Some mathematical functions which you can apply on NumPy. So np.array, these are the angles given to you. If you want to calculate sine of different angles, np.sine is a function. np.sine a into npi pi upon 180, because you have to convert this to radians and then you have to calculate the values. So similarly, np.cos will give us cosine, np.tan will give us tangent, and there are some more. So sine, cosine, arcsine, then you have degrees, then you have np.cos, arccos, np.degrees, arctan, tan. These all functions can also be executed using NumPy arrays. So this is about the NumPy which we wanted to see, because NumPy is going to give us an important object which we can use in our data analysis. Let us move on to the next library. And then the next library is Pandas. It is a very efficient data frame object with default customized indexing both. Okay, default and customized indexing. Tools for loading data in memory objects from different file formats. So in this Pandas, using Pandas, you can load the different types of files. So we don't usually create a file in Python. What we want to do, we want Python to do data analysis for us. So what we will expect that we should be able to load our data in this particular platform, and we should be able to execute some statistical operations, or we should be able to execute some analysis tools on that data. So here in Pandas, you can accept or you can import the values from different files. Data alignment and integrated handling of missing data. So missing data can also be handled. If there are missing values, you can remove those missing values, or you can replace those missing values. There are default functions for that also. Reshaping and pivoting data sets. You can reshape and you can even pivot the data sets as per your need. Label-based slicing, indexing, and subsetting also takes place in Pandas. Columns from a structure, data structure can be deleted or inserted. So you can add or remove a column. Group by data aggregation function. So suppose you have a data in which you have repeated values in a particular column and you would like to group that data. That can also be done in Pandas. Tools for merging and joining the data. You can join the two data sets if they satisfy the certain conditions. And even time series analysis tools are available in Pandas. So Pandas give us data structures. So there are basically Pandas. First, PAN represents panel, DA represents data frame, and S represents series. So these are three different data structures which are available in Pandas. So the most popular data structure, because we deal with the data in tabular format, which is two-dimensional data, right? So that is the most popular data structure here. And series is one-dimensional data structure, data frame is a two-dimensional data structure, and panel is three-dimensional data structure. Now what we will do is we'll see some more libraries which can be useful, and then we will see how to work with data using data frames. So the next library is Matplotlib. This library is basically for data visualization, and it provides the methods to visualize the data in more effective way. There are many tools available to draw the charts, and it is useful to draw the line chart, pie chart, histograms, bar charts, and many other charts. It has interactive features like zooming, panning, and saving the graph also. So you can use those features from Matplotlib, and you can draw various graphs. There are many attributes attached to the graphs. You can use those attributes as well in Matplotlib. We'll see these examples as well later. The next library is SciPy. SciPy is a Python library basically for data science and scientific computing. It provides the functionality to scientific mathematics and computing. Basically, it has more of mathematical modeling, modeling modules. And one more module it has, which is more popular among statisticians, is stat model, which has almost all statistical analysis techniques over there. And that stat model, we will visit to the page of stat model where there are some examples illustrated about stat model as well. And the next library is scikit-learn. This library is basically for machine learning. So various algorithms and functions which are used in machine learning are stored in this library. So this library is not a library that it has been generated on a single platform, or it has its own identity. Rather, this particular library is generated using the functions which are present in NumPy. Yes, Pallavi? Yes, Pallavi, you have raised your hand. Pallavi, ma'am. Do you want to ask something?
It may be by mistake.
Okay, thank you, sir. Okay, so it is built on NumPy, SciPy, and Matplotlib. So functions and attributes which are present in or methods which are present in NumPy, SciPy, and Matplotlib, those are used to design the methods in Scikit, and it provides easy and simple tools for data mining and data analysis. Let us move ahead and. Okay, so this slide I could have kept earlier because we have already used NumPy. How do we load the libraries in our program? Import NumPy as NP, import SciPy as SP, import Pandas as PD, Matplotlib as MPL, and as SKL. Again, let me tell you, this as and whatever we write after as is an optional part, but rather than writing Matplotlib again and again, it is easy to write MP, MPL or something. So because every method and every attribute, when you have to call, remember you have to write the library name first. So that is the reason we use alias for that purpose. So this is how we can import the libraries. Now working with data. So let us start working with data. So first thing is you would like to load the data in your program. So a data frame is an important object, as I told you, pd.read_csv, and this data file. Suppose iris data set is stored on my desktop. So how will I copy this address? I will go to that file on desktop, will hold shift key and right click, and there is one option called copy path. We will paste that path here, and that path will be pasted over here. When this is useful, when you are using Python on your system, which is installed software. So either Python 3, Anaconda, whatever, whichever software you have installed. If you want to use that data in that particular software, then you can use pd.read_csv command, and you can execute this command, and then that data set will be available to you for further analysis in Python. Before we write this pd.read_csv, please remember, because we are using PD, that is Pandas, we have to import Pandas. So before this, the statement will be import Pandas as PD, and then you can write this statement. But if you are using Google Colaboratory, so then you will have to write some code over there. From Google Colab, import files uploaded is equal to files dot upload, and you will be able to upload these files. Once you execute this, it allows you to choose a file which you want to upload. Then you choose that file gets uploaded, and then you can read that file. Okay, only uploading is not sufficient. If you want to use that file, you have to read the file in data frame. So we will see how to upload this file in data frames. Let me just. And other formats also are supported, as I told you. So you may have an Excel file. I'm sorry. Okay. So you may have an Excel file, you may have Stata file, you may have SAS file, you may have HDF file. All these files can be imported in Python, and you can use the data stored in that file for the analysis purpose. So let us first import this iris.csv in Google Colaboratory so that you all can try this later. I'll go to Google Colaboratory to check if this link is working. Okay, so okay, I hope you all can see this Colaboratory screen now. from google.colab import files uploaded equal to files.upload. I will execute this code. Okay. So in Google Collaboratory, how do you use Google Collaboratory is, first let me tell you that also. If you are here, you can go to Google, you can just type Google Collaboratory and this welcome to Collaboratory you can click on. If you have any collaboratories, it will open the file with those collaboratories. If you don't have any, I can click on cancel. This page will be open with you. And you want to make a new file, you can go to you can go to file menu, select new notebook. Okay, so this is the new notebook with you. I hope you all can see this. This is the new notebook with you. Here you can see code and here you can see text. So suppose I want to explain something about this code, which I'm going to write below this. I would like to remove this first code. So I can select that and click on this button. Now, this is some reference text. And then if you want to write some code, you can click on code and you can add a coding window here. Once you add a coding window here, you are allowed to write the code in that coding window. So what we have done is I have already typed the code over here. We will execute that code. Now see here, I had executed this and can you see choose files is here. I'm allowed to choose the files which I would like to import and I would like to use those files for the further analysis. So you can go here, choose a file. Suppose my file is stored on the desktop. I can go to desktop and this is the iris dataset CSV file and we are importing that file. Now you can see here, it shows us how much is done. Now 100% import is done. So the file is stored here. How can you see whether the file is imported or not? You can see here, the files will be shown. So this is a file which we have. Here is a file folder. Okay. Now the next step is converting it to a data type because data frame. So to convert it to a data frame, we will execute this. And the next one which I have written is the first attribute. Now let us go back to our presentation and see. So these are different attributes attributes are nothing but the properties of the data frame. So these are different attributes which one data frame can have. A data frame can have data types. It will have columns. It may have the axis. It will have dimensions, size, shape, and values. So if you want to check these attributes, how will you check those attributes? You can execute different commands. So we will execute all these commands now. Okay, so we are here. Import pandas as PD is required because we are going to use PD here. Import IO and this file I have to read. I have uploaded the file on the drive, but now we have to read this file. So to read this file, read _CSV io.bytes io uploaded because this is present in this particular address iris.csv. So if I execute df.datatypes, let us execute it. So it is going to show me the data types that are present. So there are different columns, ID, sepal length, sepal width, and so on. Okay. I'm sorry. So there are different columns, ID, sepal length, petal width, petal length, species, and so on. So what are their data types that is shown over here? ID, data type of ID is integer of 64-bit, float of 64-bit, and then others are also float values. So this gives us the data type of our data frame. Then you would like to check the another attribute that is columns. So are there in the in this particular data frame or in this particular file. Data frame is nothing but your CSV file which we have imported. So the attribute which you are going to execute is columns. So df.columns will call the attribute columns and it will give us the names of all the columns that are present here. Similarly, there are different attributes. I will just go through those attributes quickly. Ndim is what is the dimension of the data frame. Then size, how many values are there in your data frame. Size gives us how many elements are there in your data frame. So if I have 150 records and I have 6 columns, then total 900 elements are there if there is no blank element. Okay. Then df.shape, shape will give us 150 by 6, that is 150 rows and 6 columns are there in your data frame. Df pd.read underscore csv df.values, it will list all the values from your data frame. So I will just scroll down and see all the values from your data frame or from your file are listed over here. These are the attributes that are attached to your file. Now let us check what are the methods that are there in your data frames. So different methods, head, tail, describe, max, mean, median, mode, even standard deviation, sample of n values. Then drop NA will remove the missing values from your data. If there are no missing values, it will not remove anything. Similarly, these are also the methods. So describe, minimum, maximum, mean, mode, median, variance, standard deviation, standard error of mean, skewness, and kurtosis. Okay, so let us execute these methods as well for the iris data set. So we are here. Second, I think it's the wrong collaboratory open. Let me check the link again. Okay, so now, yes. So this is the data frame and we are executing one by one methods on this. Okay, so attributes were the properties and now on this you can execute some methods. Again, because I'm there in the new collaboratory right now, I will have to upload the file. So I will upload the file. It allows me to choose the file. I'll choose my file as iris dataset, iris.csv. Open it. The file is available to you. Now you can import the file. You can use the file in your data frame. So df.head into the bracket 10. So if I only write df.head and open and close parentheses, that's it. I don't write any parameter inside that. Then it will give me first 5 records or first 5 rows of the data. If I write any parameter over there, those many lines or first those many lines from the data will be extracted. Tail, similar to head, there is tail. So I have written tail 5. Even if I write only tail and open and close parenthesis, it is going to give me last 5 records in the data set. pd.read underscore csv df.describe. What this describe does is it describes the it gives us the summary of basic statistical analysis, that is count, mean, minimum, standard deviation, quartiles, and maximum value for every column which is numeric. Okay, this is applicable only for numeric columns. Similarly, you have maximum and minimum function. So for every column, they have shown us the maximum value and minimum value. Then there is standard deviation. STD is the method which is used to calculate the standard deviation. Then if you want to draw a sample of size 25 from 150 records, so you can execute this and you can get the sample of size 25. So this is a random sample which is generated using sample into the bracket n method. Drop NA, because this file does not have any blanks. Drop NA does not affect this file. df.drop NA is going to exclude those records wherever missing values are there. Then read.csv, again we are reading this file because we are executing some more. Now see here, you don't, right now we have seen all the methods which were applied on every column of the data set or every column of the file. We don't want to apply it on every column. I just want to calculate the variance on petal width. So you can specify that column name after df, that is data frame name. It is not necessary that df will be only the data frame name. You can have any name to your data frame. I could have written iris. If I write iris as a data frame name, iris into the square bracket, into the quotes, I'll write the name of the column for which I want to calculate the method. So into the quotes, we have written petal width cm because this is the column name. Similarly, here you can see we have written sepal length cm because this is the column name, and we wanted to calculate median for that. So data frame name followed by square brackets, and into the square brackets you will have the name of the column enclosed into the quotation marks, and then dot method gives us the output for those particular columns. If you want output for all the columns, you don't write anything in square brackets. You just write the data frame name dot the method. So here is variance is calculated, then you can calculate skewness, then you can calculate kurtosis as well. Let us go to the presentation again. I think I will go a little faster, maybe. Just a second. Okay, we were here. Okay, so here tail, max, mean, median, standard deviation, sample and drop NA we have seen. And we have seen these as well, skewness and kurtosis as well. Now writing data to CSV file. It is not necessary that you just want to accept the data from or you just want to import the data from CSV file. You may want to write the data to CSV file. Then there are some methods of writing the data in CSV file. So one is using data frame and another one is using CSV library. So how do we write it? That we will see here. Okay, so import pandas as PD, df1 is the data frame, and this data frame has some objects. Okay, import pandas as PD, df1 as data frame. Again, I have written, I think, the same thing. Okay, df1 to excel underscore output dot xslx. xslx, maybe this is the correct extension, correct. So you write this extension for Excel file and CSV for CSV file. Now, if I execute this, this is using pandas and data frames only. So if I execute this, A, B, and C, D are written in 2 rows and 2 columns. Now let us see that. So after execution of this, we will not be able to understand whether the data has been written or not. What you have to do is you can only see the tick mark here. It says that the query has been successfully or the program has been successfully executed, and you can go to this folder and you can check. Here you can see output.csv file is there, output.excel file is generated. You can download these files and check their structure. Okay. Similarly, there is another way of writing the files. One way is, see, this is a list. Okay. C is equal to some values is a list. Then R is equal to, this is a 2-dimensional list. Yes, Dilip Hajra. Have you raised your hand?
I think your screen is not visible to.
My screen is not visible. Is my screen visible to others? Or okay, I'm sorry. It was not visible. Fine. Okay, I'll explain it again. Now is it visible? Now is the screen visible?
Yes. Yes.
Google Collaboratory screen I am sharing right now.
Yes, it's visible.
Okay, thank you. So we are importing pandas because we are using first procedure, that is using data frame, and second procedure we will use CSV library. Okay, so we import pandas as PD. We define first data frame and we define that data. This is repeated. This, even if you ignore, that is fine. Then df1.to_excel is the method. The method is to_excel and the name of the file. What name you want to assign to that Excel file with the correct extension. So if you want Excel file, you will write Excel SX as the extension. If you want this to be converted to a CSV file, you will write this as output.csv. So whatever, suppose you wanted to use that 25 randomly generated 25 numbers only for some statistical analysis, what you could have done, you could have written those 25 values in a data frame, and you can convert that data. And further analysis, if you want to do using Excel, or if you want to do it on CSV file, what you can do is you can convert that Excel data frame to CSV and Excel file using this procedure. So this is one of the procedures. So I execute this, then what happens is the two files are generated. But here I will not come to know whether the execution has taken place except for the tick mark. But you can go to the folder button and you can check there are two files added over here, like output.csv, output.xlsx, and you can download those files and check. Similarly, there is another procedure. The another procedure is you can import CSV. The column names are given. Can you see C represents the field names or column names, and R represents row values. Now see how many column names. There are 4 columns given: name, branch, year, and CGP. And there are rows. There are 1, 2, 3, 4, 5 rows. 1, 2, 3, 4, 5, 6 rows maybe. There are 6 rows given, and every row has the row values according to the column names. Now what we are writing, file name is kcc.csv, or you can give any file name which you want. Now how do we write it? With open file name, comma w. W represents write. Open this file in write mode as CSV file. CSV writer, csv.writer into the bracket CSV file. CSV writer, write row. So we are writing row as column, and then write rows. What is the meaning of write row and write rows is, first row we want to add as a header. So we use it as write row. And one row is added with the column headings. And then write rows will add multiple rows, and those are these rows. And this also forms one CSV file. If you execute this here, you will be able to see that the execution has taken place. And if you go here, you can see one more KCC file is there in your folder. You can download this file and check the structure of the file later. Okay. We'll go back to the presentation. Okay. So next is graphics in Python. So there are 2-dimensional plotting. You can have 2-dimensional plotting using Python. Even 3-dimensional is also there. But we'll discuss up to 2-dimension. 3-dimension is extension of this. And there is a Seaborn library here. Using this library, so I will just give you the link of that library, and we will visit that library. This 2-dimensional we'll discuss in detail now. Of course, I will be a little faster because I just have 10 more minutes with me. Let us see how much we can complete. So Seaborn, I will show you later. Let us go to this. I'm on the last page. Okay, so access function gives us the access to figure, text, adds text to the access, X label, Y label. We are using matplotlib library here. I have not started from here. For plotting in Python, we use pyplot module, which is stored in matplotlib package or matplotlib library, you can call it as. Also, we need NumPy library for generation of arrays. And matplotlib.pyplot contains the style functions which make matplotlib work as MATLAB for drawing the different graphs. So the pyplot function is explained over here. There are different functions over here under pyplot. Bar H, horizontal bar plot, box plot will represent box plot, histogram hist will represent histogram, pie chart, plots the different line plots, scatter plot, will display the scatter plot, stacked area plot can be done, stem plot, step plot, and quiver. So you can draw many types of plots using pyplot functions. There are different figure functions. So if you want to attach some attributes, if you want to give some properties to your figure, if you want to create a new figure, if you want to add text to your figure, you want figure to be displayed, you want to save your figure, These are the functions which you will use. Then there are different access functions and okay. So there are different access functions. Access functions are to add access to the figure, to add text to the axis, X label, you want to label the X axis, you want to label the Y axis, you want to set up the limit for X axis and Y axis, you want to set the scale for Y axis, and if you want to display tick marks on the axis. So these are the different functions which are required. Again, this is not visible. Now is it visible?
Yeah.
Okay. So this I had already explained. These will be the pyplot functions: bar, bar age, box plot, and so on to design different plots. Then we have seen the figures, figure attributes. You may want to create a new figure. You may want to add text to your figure. You would like to display the figure, and you may want to save the figure. So these are different attributes. Then these are the access attributes, and colors and patterns can also be decided. So plot symbols. So it is not necessary that in your program or in your graph, you just have dots, or you cannot have any other symbols. You can have all these symbols in your plot. So you can select these symbols while writing the pyplot command. So plot colors can also be written. B, G, R, C, M, Y, K, W, all this represent the different colors. So you know the names of the colors are blue, green, and so on. So let us see how do we plot sine wave. This is a simple plot function. So import NumPy as NP from matplotlib, import pyplot and import math. So because we need different mathematical functions also. np.arrange 0 to pi by 2, no, 0 to 2 pi, we are taking the range by 0.5 interval. And then np.sinx will generate an array of sin x. And we plot x against y, y against x. Then x label can be added as x, y label can be added as sin x, and the title can also be added as sin x. So this way you can plot the different plots. Y equal to x square is in similar manner. If you want to change the pattern and the color, you can add here. So y is equal to x square. Can you see plot x comma y? We'll plot the xy values. R dot. R represents red color. Dot represents the pattern is dotted pattern. Okay. So let us move on to the multiple plots. Suppose in the same plot, you want to add few more plots, then you can have two different plot conditions, plot commands. So first plot is red line, and second plot is cos. First plot is cos function, second plot is sine function with green line and green dotted line. R and single hyphen represents a single line, a continuous line, whereas double hyphen represents a dotted line. Line plot. So this is an example of line plot. L1 and L2 are here. AX dot legends. So legends are given over here. Plot figure. It makes the place for figure to be added. Then L1 is equal to AX dot plot. Will plot your first line. L2 is equal to AX dot plot. Will plot your second line, and with different colors. Now can you see BS dash and GO dash dash? Let us understand BS is solid line, blue color, and square marker. S represents square marker. Hyphen represents solid line. B represents blue color. S represents square marker. Similarly, GO, green color, circle marker, and dashed line, because there are two hyphens. So you can see this. Even you can specify the positions of the legends as well. And this is how you can draw the line chart. Bar plot. So you have AX figure dot add access. You can add access to your figure. Then you have divisions here, one list here and another list here. AX dot bar is the function. That is, access dot bar is the function with the values on x axis and values on y axis will be given over here. So divisions, comma students, and plot dot show will show us the plot here itself. Then multiple bar plot. For multiple bar plot, you have to specify the width over here. So x plus 0, 0, ax dot bar x plus 0, 0, that is at 0th position, this bar starts. Second bar starts at the end of the 0.25. So length of that particular bar is 0.25, or rather width of that particular bar is 0.25. Then the second bar starts. Then third bar starts at 0.50 position. So here you need to specify the position or the beginning position for that particular bar and the data as well. So data 0 is first data, because here you can see we have not used three different lists. Rather, we have just used nested list. In the nested list, the first element is first bar, second element will represent second bar, and third element will represent third bar. And this type of plot can be drawn. Similarly, stacked bar chart. For stacked bar chart, now you will have to give the upper limit. Now, can you see here? Bottom, you have to specify. Maths is the first bar. Okay. Ax dot bar will draw maths bar in red color. The second bar starts with the bottom as maths bar. So bottom equal to maths represents that second bar starts with the bottom as maths. So if you have one more, then you can write math starts and physics say, and then second was starts. Then the bottom for the third bar will be starts. So this way you can draw stacked bar chart as well. This is the example. Pie chart. So to construct the pie chart, ax.pie function is used. The following example shows, so let us go to the example directly. Ax.figure axes are added over here. Equal axis, we are giving equal weightage to every axis. Then grades are specified and students are given. Then ax.pie, based on students, labels are grades, and autopack you can specify any value, and then plot show will show us the plot in this manner. Histogram, ax.hist will give you the histogram. You can see here ax.hits. A, comma, bins you have to specify. The length of the bins you have to specify where you want the cut of every histogram should be. And then H color, if you want to add H color, you can add. If you don't add it, it will not add any H color to it. Line width of H color, this line width represents the line width of this H color, which is 1.2. For the visibility, if you want to add, you can add it. So this is how you can, and these are all additional parameters, I mean additional attributes if you want to add to your chart. Title, tick marks, then labels, and so on. Scatter plot can also be drawn. Ax.scatter will give us the scatter plot, and to draw this, you can use this type of scatter plot is drawn for the given data. So this is about plotting. I'll go back to this, and this is a Seaborn library. Now we are not going to discuss the Seaborn library because time is already up. I'll just show you. You can visit this page and you can see there are many plots given over here. You can have multi-plot grids also. You can have different plotting functions here, and beautiful plots also can be drawn. So if you click on any of this, you will get the reference codes and the reference material also there. You can try these codes in Google Collaboratory to draw the different plots as well. Similarly, we will see the libraries that are just a second, I'm not able to go back to the. Okay, so we are here. Next. So basic statistical analysis, any statistician might be interested in this analysis. So stats model is the library which allows you to do all this type of and more, many more. Linear regression, ANOVA test, hypothesis testing. If you want to do, you can visit to this stat model. Here you have the reference material, as well as you will get some examples which you can try on your own, and then you can try your examples as well. I think again, these examples might not be visible, so I'll share the screen. So this is the page where you will have different topics in which stats model can be used. And the codes are also given over here. You can execute these codes and try for your data as well. And there is another library which is more used by machine learning or those who are dealing with artificial intelligence and all. They use this scikit-learn library, which is here. And there are some examples of scikit-learn library on this particular page. you can visit to these examples and you can illustrate your examples also using these libraries. So